Alright guys, welcome to the Pre-algebra 4.2 video on greatest common factor, otherwise known as GCF. So whenever you see GCF, you need to think about, greatest common factor. Okay, so let's just review real quick. What is a factor? Okay, what is a factor? Well, it's a number when multiplied by another number, it gets you a different number. Okay, so that's kind of confusing, but let's just remember really simply, if I said, what are the factors of 10, you would say, well, I could multiply 1 times 10 to get me 10, so both 1 and 10 are factors. I could multiply 2 times 5 to get me 10, so both 2 and 5 would be factors, and so here are the factors of 10. So those are factors. So let's talk about common factors. That'd be number 1. Let's go here to number 2, common factors. So let's talk about the numbers 10 and then the number 20. Okay, so we already said that 1, 2, 5, and 10 are factors of 10, right? Those are all factors of 10. What about the factors of 20? Well, I can multiply 1 times 20 to get 20. I can multiply 2 times 10 to get 20. 3, no. I could multiply 4 times 5 to get 20 though. And there's no whole numbers in between 4 and 5, so we're done. So here are all the factors. So what are my common factors between 10 and 20? Well, both 1 shows up on both of those. 2 is a factor of both of them. Okay. 4 is not, but 5 is. Okay, so 5 is a factor of both 10 and 20. And 10 is both a factor of 10 and 20. Okay, so 4 and 20 are left out down here because you don't see them up there. So those are all the common factors. So number 3 here, when we talk about greatest common factor, well, it's pretty self-explanatory, right? Out of the common factors, which one's the greatest? Well, if we're talking about the numbers 10 and 20, so if I want to know the greatest common factor of 10 and 20, I'm gonna have to look at all the factors that they both share. So the common factors, so only the ones that are circled in red here, and say which one's the larger one or the largest. It'd be 10. All right. So there you go. That's greatest common factor in a nutshell. So why don't you take a second and I want you to try this one. I want you to find the greatest common factor, okay, of 12 and 30. So pause the video, try that, play it when you're done. So how I like to do this is usually I'll set it up vertically. I'll do 12 colon 30 colon. I'll say, all right, what are the factors of 12? Well, I know 1 times 12 gets me 12, so let's start there. I know 2 times 6 get me 12. I know 3 times 4 get me 12, and there's no whole numbers in between 3 and 4. That multiply to get 12. There's actually no whole numbers between 3 and 4, period. So there we go. I have all my factors of 12. 30. Okay, 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. 4, no. 5, yeah, 5 times 6 is 30. And I'm done because there's no whole numbers in between 5 and 6 that multiply to get 30 or that exist anyway. And so now I just look at my factors, figure out which ones are common, and then what I usually do is I don't circle anything but the greatest common one. You can circle all the common ones and in a different color circle the greatest, doesn't matter. So let's see, they both share a 1. Okay, that's fine, but is it the greatest? No. They both share a 2. Both share a 3. 4 is not common, 5 is not common. They both share a 6. And then let's see, 12. He doesn't share a 12. Now, keep in mind, the greatest common factor between these two numbers couldn't be any more than 12, right? Because 12 is the biggest factor of 12, and there's nothing beyond it. So I definitely know it can't be 15, right? It can't be 30. Now, anything under that, it could be, but again, we're looking for the greatest common. 6 is the largest number that's shared between both of those lists of factors. And so what is our greatest common factor? 6 of 12 and 30. All right, now there is another way of finding the greatest common factor. Okay, so let's try it a different way. What we're going to do, we're going to find the greatest common factor of 12 and 30 again. And we already know it's 6, but let me show you the other way. Okay, the other way would be to write the prime factorization of each number. So we're going to look at 12 and 30 again. Okay, so what's the prime factorization of 12? Well, again, I have to do a factor tree. Let's see, how about 3 times 4? That gets me 12. 3 is prime, so I circle him. 4 is not, so I break him up into 2 and 2. Those are both prime. All right, so I'm going to write out for 12, the prime factorization would be 2 times 2 times 3. Now, I could make this 2 squared, but I'm not going to, and I'll show you why in a second. Now 30, the prime factorization of 30, let's do 3 times 10. 3 is prime, circle him. 10 could be broken up into 2 times 5. 2 is prime, 5 is prime, I'm done. So, prime factorization of 30 would be 2 times 3 times 5. All right, and now what do? Well, now I'm going to circle everything they share. Okay, so they share a 2, right? So 1, 2 from 12, 1, 2 from 30. Now, what else do they share? Well, he has another 2, but he does not, so I can't circle that other 2. Now, I see a 3 on both of them. Okay, so I circle the 3s. This guy has a 5, but he does not, so I'm done-ish. But now what I do is I multiply their common factors that came from the prime factorization. So 2 came from right there, times 3, which came from that shared factor, and 2 times 3 is 6. And that right there would be my answer. And if you look, let's go up here, what was the greatest common factor when I listed the factors and circled the largest one? It was 6, right? So either way you want to do it is fine. I prefer this method personally. However, when you get into larger numbers, sometimes doing the prime factorization way is maybe a little bit more beneficial. Either way is fine. All right, so I want you to pause the video and I want you to try that one. Okay, I want you to find the greatest common factor of 27, 45, and 90. Okay, so pause it, try it, play it when you're done. All right, so I'm going to use the first method where you just list out the factors, okay? So I'm going to set it up vertically, 27 first, then 45, then 90. Does it matter what order you go in? No, okay? Now, let's keep in mind, the largest factor that could be the greatest common factor would be 27, right? Because you know, there's no number larger than 27 that can be multiplied by another whole number to get 27. So let's keep that in mind as we go forth. Now, 27, I can multiply 1 times 27, right? And is 27 prime? No, it's not. Remember, I could also take 3 times 9. Now, is that it between those two numbers? Yeah, right? 4, 5, 6, 7, and 8 are not factors of 27, so I'm done there. Now, how about 45? Well, I could take 1 times 45, okay? 2, no, yeah, 3, I could do 15, okay? I could also take 5 times 9, and is there anything in between 5 and 9 that multiply together to get you 45? No, there's not. 6 doesn't work, 7 doesn't work, 8 doesn't work. So, are we done? Now we got one more. Okay, so what about 90? Well, 1 times 90 gets you 90. 2 times 45 would get you 90. Okay, 3, ooh, that should be a 3 there. 3 times what? 30 would get you 90. 4, no. 5, yeah. 5 times what? 5 times, well, 5 times 20 will get you 100. So we need 2 less 20, or 2 less 5, so it'd be 5 times 18. We'll get you that. That doesn't look really good. 5 times 18. Okay, what about between 5 and 18? How about 6? 90 divided by 6, does that work? Yeah. Okay, 6 times 15. We'll keep dialing it down. I probably didn't give myself enough room there. How about 8? 90 divided by 8, does that work? No, it gets you 11.25, so that would not be a factor. But how about 9, right? We know that 9 times 10 would get you 90. Now, is there a whole number between 9 and 10 that multiply to get 90? No. Okay, so now we got to find the greatest common factor. Keep in mind, it could be no bigger than 27. So I know that 45 won't work, 90 won't work, 45 won't work, 30 won't work. So that limits my choices here. And let's see, is 27 a factor of the others? No, it's not, so he won't work. How about 9 though? 9 is there, 9's there, and 9 is there. Okay, now keep in mind, these guys both share a 15, but 27 does not. So 9 is the largest number that shows up in all three lists of factors, so the greatest common factor there is 9. All right, so let's talk about being relatively prime. Okay, so when we talk about relatively prime, we're talking about more than one number, so 2 numbers, 3 numbers, 4 numbers, 7 numbers, whatever. And they are relatively prime, okay, so to each other, if their greatest common factor is 1. Okay, so how about, let's see, 30, let's do 35 and 54. So how can I tell if they're relatively prime? Well, let's list out the factors of 35 and then 54. Okay, so 35, 1 and 35, 2, 3, 4, no, 5, and 7. There's nothing in between those two, so those are all the factors of 35. How about 54? Well, obviously 1 times 54. Okay. 2 times 27. Okay. 54 divided by 3, does that work? Yeah. Okay, so 3 and 18 multiply to get 54. 4, no. 5, no. 6? Yeah, actually 6 times 9 gets you 54. How about, see, 7 or 8? 54 divided by 7, no. 54 divided by 8, no. And so those are all the factors of 54. So which is the greatest? Well, they both share a 1, that's good. Okay, a 5, does he have a 5? No. He has a 7, but does he? No. He has a 35, but does he? No. So 1 is actually the greatest common factor between those two numbers. Now, are these numbers individually prime? Well, no, because I can multiply 5 times 7 to get 35. Okay, so there's more than two numbers, two factors that multiply to get 35. Same thing here. 54 is not prime on its own. But if you compare the two, we say that these two, yes, are relatively prime. Okay, it's relatively prime because they're only prime to each other. They're not independently prime, but they are when you compare them to each other because their greatest common factor is 1. All right, so let's find the greatest common factor of monomials, which technically we've already done because, like up here, we found the greatest common factor of 27, 45, and 90. Those are all monomials technically because they're just plain, numbers, whole numbers. But let's add in some variables. Okay, so what we're going to do is we're going to find the greatest common factor of, let's see, this is going to be number 8. We're going to find the greatest common factor of 18xy squared, and then 28x, we'll do x squared, y squared. Okay, so how do I do that? Well, let's think about how we, in the past, factored monomials. Okay, well, remember, we factored them by writing these things out in product form. Okay, so how do we do that? Well, remember, we did the prime factorization of the number part first. So we're just going to deal with 18xy first. Here, we're going to do a tree, factor tree, right? So let's see, 18 can be broken up into 2 times 9. 2 is prime. 9 can be broken up into 3 times 3. Both are prime. All right, now we're going to write the xy squared in product form or multiplication form. So that's like saying x times y, right? And so we put all these things together. From here, we get 2 times 3 times 3, and I'm not going to write this part as 3 squared in here, and this is why I told you in the last video. You'll see in a second. And then I bring down the variables, times x times y times y. Okay, now if you do 2 times 3 times 3, well, that's 6 times 3, that's 18. X times y is xy squared. Okay, so this is just a rewritten form of that. Now let's do the same thing over here. 28, number part, we're going to do a tree. Okay, so factor tree for 28. 4 times 7, he's prime, 4 is not. Let's do 2 times 2, both of those are prime. Now let's work on the variables. We're going to write that as repeated multiplication. So that becomes x times y times y. Put those two things together, we get 2 times 2 times x times y times y. Okay? Now, we're going to find the greatest common factor of these monomials. So I'm actually going to move him down and line him up under that one. So we got 2 times x times y times y. All right, so he just went right there. So again, greatest common factor, we're trying to find the largest numbers, okay, that multiply, that are factors of both 18 and 28. Okay, so we're going to just pick apart the number part first. So do they both share a 2? Yeah, so let's circle that those 2's. Do they both share 3's? No, they don't. Okay, he has 3's, but he does not. So I'm done with the number part. So I already know part of my answer is going to be 2. Now how about the variables? Well, again, we're going to circle what they share. Okay, they both have an x to give. So there's part of our answer, an x. They both have a y to give. So there's another part of our answer. We got a y. And they have another y to give. So there's another part of our answer. And instead of writing y, how should I probably write that? Well, let's write that y squared. Okay? That's all they share, and you are done. That is how you find the greatest common factor of two monomials that have variables in them. All right, so I want you to take a minute, try that one, and then play the video when you are done. Okay, so finding the greatest common factor of these two, I'm going to start with this one first, and I'm going to use the 15 and break that up into a factor tree first. Okay, so the factor tree of 15 becomes 3 times 5. 3's prime, 5's prime. I'm done with that part. And I'm going to write the x squared part as repeated multiplication, so that's just x times x. Put all that together, you get 3 times 5 times x times x. Okay, you're done with that. Now move on to 6y. Got to do a factor tree for the 6, so that becomes 2 times 3. 2's prime, 3's prime, done with that part. How do I write just one y as repeated multiplication though? Just like that. Okay, there's only one of them. Okay, I don't have to write it times anything. But if I combine all that, I get 2 times 3 times y. All came from right there. So now I'm going to line them up. Bring him just down there, so it's just lined up. 2 times 3 times y. And now I circle what they share. All right? And if you notice, the only thing that they share is a 3. Okay, they don't share a 2, they don't share a 5, they also don't share variables. So what is the greatest common factor of 15x squared and 6y? It's just the number 3. Okay, I understand that they both have variable parts, but they don't share any variables, so those variables can't be a greatest common factor, so you're done. It's just the number 3. All right, guys, that's all I have for you. I look forward to seeing you in class and talking about this.